Hello friends, welcome back. In the previous tutorial, we have learned how to get the direction vector, how to find out the distance between two game objects. Let us proceed further and get some more information. Now first of all, I can say distance is not a vector. I can say distance is the length of the direction vector, guys. Distance is the length of the direction vector. So first of all, I need to get the direction vector from player to the enemy, right? How do we get that, guys? We subtract player position from the enemy position, right? That is EP minus PP. Let's come back to the code and write some code. So here we are. So if I need to get the vector from player to enemy, I should say E position minus P position. Here we have the player position vector 2D created 200, 200, and we have the enemy position vector 2D 600 and 200, and we created a direction vector, and that direction vector we are going to get by subtracting the player position from the enemy position. And we know that the value that we are going to get is 600 minus 200, which is 400. 200 minus 200 is 0. So direction vector we are going to get 400 comma 0. So I say debug.log, and I can say direction vectors x is equal to 0 and y is equal to 1 double quotation comma direction dot x comma direction dot y bracket close semicolon. Here I am going to say string dot format bracket close. Now this gives us the direction vectors x component and y component. We can see over here. I can save and come back to Unity just to show you that we should get 400 and 0 output. And you can see that we got direction x equal to 400, y equal to 0. So this is how you are going to get the direction vector, guys. And you can see in the image also it shows that 600 minus 200 is 400. So you can see 100 units, 200 units, 300 units, 400. In x and y is definitely 0. That is the direction vector we got, guys. Now if I want to find out the distance between 2 points, or I can say the length of the direction vector. Length of the direction vector is actually the distance between 2 points, guys, these two game objects over here, right? That is the distance. Distance is actually length of the direction vector. Very simple. And how do we do that one? How do we find out? Very simple. We know that one already. Debug.log. I can say direction vector dot magnitude. This will give us the distance, right, guys? So I can say here string dot format in double quotation. I can say distance is equal to in double quotation 0 double quotation comma bracket close. So here you can see that the magnitude, we know that it is going to calculate the square root of x square plus y square, Pythagoras theorem. It gives us the magnitude of the current vector, that is the direction vector. If I save and run, I should get the magnitude 400, that is the distance, right? You can see the distance is 400. Now let us come back. Now you can see that as a programmer, if I have to find out the distance, I have to find out the direction vector first, then I should find out the magnitude. Instead of that, we can create one simple method. So let us create one simple method which helps us to perform get the distance. So I'm going to create one method called as public returns a vector 2D, and the method name is distance. This vector 2D is going to take two vector 2Ds, another vector 2Ds. First one is A and another vector 2D, and that one is B. It takes two vectors, and what it returns, guys, it returns, you can say like, first it finds out the direction between A and B. Let me cut this from here just to explain you step by step. You can see here I'm creating one temporary vector 2D here. I'm creating one temporary vector 2D in the distance method, which is going to be a direction vector. It gets the direction B minus A, gives me a vector from A to B, or I can say A minus B, let us take. Then I get the vector from B to A, that is from, you can think like we are going to get the vector from enemy to the player. Now let us understand step by step. Anyhow, so we are going to get the direction vector from B to A in this case, right? B to A we get. Then we can say direction dot magnitude, right? Here this returns whatever the direction vector we calculate here, then we can get the magnitude back. Instead of performing this operation, we can do like this. We can write this in this place. In a bracket I can keep this much, and I can delete this complete part, guys. In one line, what we do means we first say A minus B. What A minus B does? It gives a direction vector from B to A. Then we get the magnitude, guys, of that vector. So in this place you are going to get a resultant direction vector. Then we get the magnitude of that. Very simple. So here this time if I have to get the distance, then what I can do means I can just say, okay, so I need to make it static so that I can be able to access it by the class name. So I make it static. Let us take this one is a static method. Then what I can do is I can say here vector 2D dot distance. You can see that we can get the distance now by passing A and a B vector. Now this is a place where you need to take care of from which side, anyhow it is not much mandatory to get the distance which vector you pass first. So I can pass here distance function, and I can pass player position comma E position. I can pass enemy position, and of course it returns a float. That also you should remember, because distance is going to return the magnitude, and magnitude is the single value. We know that it returns the float back to us. Now you can see what we are doing. Try to understand here. We created the player position 200 200, enemy position 600 200. Very simple. We are calling the vector 2D dot distance function. We are using the class name, method name, because it is a static. It's a class method. Then we pass the player position. Player position will be copied to A. Then we pass the enemy position, that will be copied to B. Right, guys? Then here what happens? A minus B will be calculated. That means what is happening here means you are getting the vector from B to A. You can simply say something like this. You are getting a vector from enemy to the player. You are getting this vector there. Then you are finding this direction vector's magnitude or the distance by using the magnitude property. Now this time if I save and run, I should get here 400. Let us save and check it out. I have missed somewhere the brackets, I think so, over here. Let me save and come back to Unity, and if you run the code, you can see that we got distance 400. And if you are finding the distance, it is not necessary for us that which vector you are passing first, E position, then I pass the player position, because distance vector we can anyhow get. There is no problem which vector you pass, because it is independent of the direction. The distance is not dependent on the direction. So if you pass E position and a P position, if I save and run, I should get 400 only. There should not be problem. You can see that we got the distance 400 only. But when you are getting the direction, if you want to calculate the direction, at that time you need to take care of. Understanding? At that time you need to decide whether you have to do P minus E or E minus P. E minus, or you can say whether you have to, if you want to get the vector from enemy to player, then you have to subtract PP minus EP you should say. If you want to get the direction vector from player to the enemy, then you should subtract EP minus PP you have to do. That you should remember. To get the distance, you need not to worry about. Now why I am explaining this one, why I am explaining this distance function to you, why we created this distance function, the reason is, you can see here, we have the Unity's scripting reference. There we have a vector 2D structure, right? Representation of a 2D point. Now here you can see there is a method in the static functions list. You can see there is a method called as distance. What it does, it returns the distance between A and B. If I click on this, you can see what it is doing, guys. It is a static function. It returns a float and its name is distance. Take vector A and a vector B. Same thing we have done. And also what it returns, distance between A and B. And what you need to, how do you call it? You just need to say the structure name, then the method name, then pass the A vector and the B vector. Is the same as, you can see that, A minus B dot magnitude. The same thing I have written here, A minus B dot magnitude, guys. Now I hope you guys have understood what is the distance function or what distance function does in our Unity. Understanding? And how do we use that one in our code? So this is really useful. You can call this distance function anytime and check out whether the distance between two objects is less than 100 or something like that. If distance is less than 100, start shooting or start chasing or start evading or any other operations that you would like to do. So it's interesting. I hope you guys have understood what is distance function, right? Now already we have seen how we can use the plus operator, how we can use the minus operator, and we have created our own distance method to get the distance between two vectors. And we have seen the set method, we have seen magnitude property, we have seen square magnitude property, XY properties and fields. Let us proceed and get some more information step by step so that you guys can understand this vector2 class or structure completely, so that you can use this very easily in your games. As we are discussing about the direction vector, getting the direction vector from one point to another point, or getting the direction vector from one position to another position, or from one game object to another game object, you can see that there is no method named as a direction which returns us a direction. There is no method which returns us the direction from one point to another point. We don't have such a facility at present in vector2 structure in the Unity. If you need to get the direction from one vector from one vector to another vector, or from one object to another object, from one position to another position, then definitely you need to create a vector 2D. Let us take the direction vector I create, and I can say here new vector 2D, and then I am going to calculate the direction vector. Now here comes what I need to write here. If I have to get the direction vector from player to the enemy, from player to the enemy, then I have to subtract EP minus PP. I should write here enemy position, E position minus P position, which give me a direction vector from player to the enemy, and it is really useful. Or if you want a direction vector from player from enemy to the player, then you will be writing first player position, next you will be writing the enemy position, guys. Understanding? This is how you get the direction vector. Now you have the enemy position to the player position a direction vector. And let us see now. At present the enemy is at 600, 200, guys. That is good, nice. Now let us take, I want to move the enemy, and I want to hit, or I want to make the enemy to chase the player. So it's very simple. What we can do is we can say current enemy position, E position, is equal to enemy position whatever the enemy position is at present, plus the direction vector if I add, you should see that enemy position is going to become equal to the player position. That means enemy is going to come and stand on top of the player, or you can say that it hits the player, you can say. Understanding? Or maybe you can take a bullet or some other enemy. So this is a good example I can say. Now in one step you just make the enemy to sit on top of the player. Let us see that. I can display, I can say debug.log, I can say string.format, and I can say here ePosition x is equal to 0 and y is equal to 1, double quotation, comma, I can say ePosition.x, comma, ePosition.y. You should see the result as here 200, comma 200. Let us save now, come back to Unity. If I run the code, you should see that in one step you have moved the enemy on top of the player. You can see that enemy position x is 200, y is 200. But usually we won't do like that. Chasing means what, guys? Enemy will slowly move towards the player, right? Slowly. Or you can say in one frame it moves here. In the next frame it will be over here. In the next frame it will be over here. In the next frame it will be over here. So you can say 1, 2, 3, 4. After 4 steps it has to reach to the player. That is actually the chasing, right? Correct or not? So how do we do that one? We can do in many different ways. One way I can say is, if I divide the enemy's vector by 4, let us take, if I take the direction vector's x component divided by 4, I take the y component divided by 4. Then what we get, guys, you can just think like at present we have the direction vector x is 400, right? X is 400 and we have y is 0. 400 divided by 4, I get 100, right guys? I get 100. And 0 divided by 4, definitely I get 0. And if I assign that to the direction vector's x component, and if I assign that to direction vector's y component, x will be 100, y will be 0, guys, right? Then you can think like, now the direction vector looks like this, right guys? So what we are getting over here, we are getting, it should be here, that is okay. I have not displayed the direction vector. Direction vector is actually minus 400, right guys? Debug.log. Let us display the direction vector also. String.format, in double quotation I can say direction x is equal to 0 and y is equal to 1. In double quotation I can say direction.x, comma direction.y. You should see here minus 400 and 0. Let us come back and run the code. Of course you know that very clearly. Already you know that we are getting minus 400 and 0. That is the direction vector. So in our calculation it should be minus 400 by 4. So we get minus 100. That is going to be the x and y. Let us calculate that one. It is easy now. Now here what I do, instead of saying like this, e position plus direction, before doing that, what I do, I say direction vector dot x should be equal to whatever the direction vector dot x at present divided by 4. 4, instead of saying 4, I can create one variable with the name number of steps. So I can create here one variable with the name as a byte type, I can say, or I can say an integer type. We can say steps. How many steps it should take to move? How many steps it should take to move or reach to the player? 4 steps. So instead of saying here 4, I can simply say steps. I can decide how many steps it can take now. If I change here 10, then we divide it by 10. Are you guys understanding? Very simple. So direction dot y is equal to direction dot y divided by number of steps. Then what I do this time, we are going to add enemy position plus direction. You should see now the enemy should be moved only 100 units to the left. That means the enemy position should be x 500, y 200. Let us check it out. If I run the code, you should see the enemy position will be 500, 200 guys. Can you see that? Only 100 unit it has moved this time. So you can think like your enemy is now currently at present in this place, right? It is changing slowly. It is going to move left as we add. Let us add one more time. Let us take the current enemy position and add once again and display the result on the screen. So here what we are doing guys, we are taking the current enemy position, adding again the direction vector. Direction vector is what? Minus 100, 0, that we are adding to the enemy position. So 500 minus 100 is 400. So x should be 400, y should be 200. Let us save and run the code and see. You can see that enemy has moved 400, 200. That means the enemy is present now at present over here, right? You can see that it is slowly moving towards the player. You can decide how many steps it should take to reach. It is all about math, little bit math calculations you should know, then you can good to go. So copy this and paste. This is the third time. Let us run and check. I'm just going to clear this and run the code. And you can see that enemy position x is 300, y is 200. Nice. That means at present the enemy is over here. Can you see that? It is almost near to the player. Still it is not collided, you can say. So if I perform one more step, I can copy this and paste it down. I save this. So you can see 1, 2, 3, 4. That is 4 steps. Let us save and come back. If I run the code, you should see now the enemy is exactly on top of the player. That is how you can move. You can move the bullet or whatever it is. It is all about the game object that you take. Are you guys understanding? You should say here 10 steps, then you have to add the direction vector to the enemy position 10 times so that the enemy moves. You can say like direction vector is something like a velocity vector, right guys? It is almost kind of a velocity vector, right? Now, this is a way how you can chase or move a game object step by step near to some other game object. I hope you guys have understood clearly how the direction vector is useful to perform different operation in your game. So now at present the enemy is over here. They both hit each other. You should also remember that whenever the enemy is moving, its position vector is changing guys. That you should not forget. Right? This is how every step the enemy position has got changed. You can try yourself. Try to find out the direction vector from player to enemy and start moving the player towards the enemy, right? Or keep the enemy somewhere else. Maybe enemy will be over here and the player will be over here. Make the enemy move in this direction or move the player from here to the enemy. Just little bit logical thinking you need. That's it guys. I think for this tutorial is this much is enough. I hope you guys have understood how direction vector is useful, how you can find out the direction vector and the distance vector. I hope you guys have clearly understood. So keep learning, keep coding guys. In the next tutorial we understand the next concepts of the vectors. See you in the next tutorial. Thank you very much.